Hi, I'm Ramona Martinez,
And I'm Catherine Sterne from Bloomington High School in California.
and we will be exploring graphs through video game simulation. I've been working at Bloomington High School this is going to be my 4th year. I've taught everything from pre-algebra, algebra 1, geometry, and I've recently started teaching Avid.
This will be my 9th year at Bloomington High School, and in the previous 8 years I've taught pre-algebra, algebra 1, geometry, honors geometry, algebra 2. Basically, if it's below pre-calculus, I've taught it. And this year we're focusing on pre-algebra and algebra 1.
And we've had the pleasure of working with Rebecca Mazzone,
a computer programmer here at NASA. She works to combine different simulation data to make a visual product of what's going on with different simulations, and we are modeling that in our lesson with the use of the coordinate plane to place and direct objects in a simulation and to visualize multiple data and multiple metrics within a single simulation.
And Rebecca takes data to create an environment, to make meaning, to bring meaning out of it, and this inspired us to design our lesson around a video game. And so we're basically we're modeling paths with linear equations through a video game simulation.
And so this is intended to be the unit that ends, the activity that ends a linear equations unit. So at this point, the students theoretically know how to graph a line and how to write equations of lines, but this is your last chance to kind of put all that together and make sure they really get it before we're going to give them a test on this unit. We're also going to work on analyzing graphical representations for different types of information within a graph or within multiple graphs.
This lesson is intended for 8th through 10th grade students or pre-algebra and algebra 1 students.
So the prerequisites that we're expecting them to bring in are they should be able to plot points on the coordinate plane, they should be able to find the slope from the graph of a line, in order to write the equation of a line, they need to be able to simplify algebraic expressions, and they need to be able to evaluate algebraic expressions.
So what we want our students to get out of this lesson is, well, it's a review lesson, so they're graphing lines on the coordinate plane, and they're writing linear equations in slope-intercept form and point-slope form, given the graph of a line.
And they're also going to be writing the equation of a line from 2 points if they can't do it from the slope and the intercept. And they're going to be interpreting the meaning of specific parts of a line graph in terms of the situation represented. So is this indicating a map? Is this indicating power metrics? What exactly is this indicating in the situation? Now, we've got an awful lot of standards that really fit here. And in California, we're always focusing on the California Algebra 1 standards and what's going to be important for the high school exit exam, it's Casey. And so specifically, obviously, if we're graphing lines and writing equations, we're going to be focusing on these 2 standards, one of which is graphing lines and one of which is writing equations. Those are reflected really well in the Common Core standards that are going to be normal nationwide by 2014. And the nice thing about the Common Core standards is that they also include the modeling aspect, that students are expected to represent relationships, and so modeling is going to become really, really important as we move to the Common Core standards. Finally, the California High School Exit Exam doesn't just cover high school algebra, it actually goes all the way down to 6th and 7th grade math standards. So we're going back to looking at how those quantitative relationships are being represented graphically and interpreting those graphs to help our students prepare for the Casey, which they take as 10th graders, not 7th graders. We're also looking at justifying their mathematical conjectures based on the graphs.
And these are really important standards. They're called power standards for the California Standards Test and the California High School Exit Exam. So they're really important standards, and we wanted to cover them in a lesson that would be interactive and
engaging. Fun.
Okay. So on the first day, we're going to compare and contrast video games, the graphics that are used now, and the graphics that were used when we were younger. So now students are used to seeing graphics like the ones in Halo, and these, I'm going to show you a video. These are more third person. These are more first person perspective. Lifelike. They're lifelike graphics. They're Halo is usually played in a more third person or first person perspective, and usually we do see the HUD, the heads up display around the screen. But that was just a trailer, and then we're gonna go back and compare that to the older version, Nintendo version of Zelda, where we can see that it is played in a orthogonal view. And I'm pretty sure you guys saw the green power meter and the the little hearts across the top. That's a heads-up display, and it was really good example because you can see the coordinate plane on that on that little section of the game, and that's pretty much what we're gonna do in our lesson. We're gonna use that same idea where we're mapping out on a coordinate plane, and they have to navigate their way through that map.
And most of our lesson, most of our activities are pencil and paper because we wanted something that would be easily accessible for just about any teacher or any student, regardless of what technology resources they had available to them.
Yeah, our lesson is something that is ready to go. Any teacher can pick this up at the appropriate time, but it's something that is easily useful. You can use it right away. Okay.
So we'd like to show you various pieces of the lesson. And on this particular assignment, there's the mouse. We've got equations down here at the bottom, and students are going to use those equations to get from point A over here on the y-axis and to move around all those obstacles to get over to point B, our end point over here. And so when we grade this, we're going to be grading on accuracy. Are they actually drawing the straight lines? Are they actually graphing all the lines correctly? And it's a really good just quiz before a test, just to let us know, do our students actually know what they're doing before they get tested.
And on that same day, they're going to have a different map where they will be choosing waypoints, which helps navigate the character through the map. So they'll choose a waypoint, maybe say here, and then they will use those 2 points and write a linear equation from the 2 points, and then they can choose another waypoint, maybe over here, where they can maneuver their way through the obstacles and arrive at their point D. So they're moving from point C to point D, choosing waypoints throughout the map that'll help them navigate themselves through to the end point.
And again, we plan on grading this as for accuracy. Did they actually graph everything? Did they actually match the equations with the lines correctly? And at the end of each of these worksheets, we've also put in a component where they compare to a neighbor or discuss with a neighbor and see if they can come up with something better. And there's a logic behind that. We're trying to make sure that there's something that keeps students who finish a little bit faster than everybody else busy for just a little bit longer. But students who need a little bit more time to get through the assignment, there's something to let the quicker students move on as well. So another assignment to work on. There's one more assignment on day 1.
And this is where the students create their own map. They draw their own obstacles here, and they choose their starting point wherever they want, and they choose their ending point on the other side, and they draw their own course again, and then they trade their papers with a partner, and they try to have their partner come up with a shorter, more direct route, or maybe a more efficient route to get to the end.
And we would actually grade this paper slightly differently than we would grade all of the others. We would grade it on a rubric instead of grading it for accuracy. Every single student is going to have something completely different on this, so we'd be looking at 3 different aspects. We'd be looking at their completeness. Did they actually answer all of the questions that were on there? Did they actually complete all of the pieces? We'd be looking at their accuracy. Have they labeled their points correctly? Have they written the equations with lines to match the lines that they've graphed? And then we'd be looking at their creativity. How many different kinds of slopes have they put in there? Is it all horizontal and vertical lines? That's just boring. Have they put anything in with, say, positive slope or negative slope? And so trying to get them to do something a little bit more interesting, a little bit more creative. And to finish off that day, to finish off that lesson, we would be having a conversation with our students, a discussion, and the topic for tonight, for that particular day, would be how are NASA rovers like video games?
And the idea of using waypoints is something from what NASA uses to navigate their rovers on a course, and a way to get around known obstacles such as craters and big boulders and the like.
And so on the second day, we got a little bit more complicated. We decided that a video game's not any good unless you've got monsters.
Do you want to show this in person?
Yeah, this is what we have to do.
We'd like to show you this in person. Okay, so
we do have a start point, which is way over there. Maybe you should point to it, Ramona. You're
right
closer.
here. Here's the start point. The start. We do have our heads-up display, our HUD. Here's our power meter. Every student is going to start with 100%, and this is our example, actually, that we're going to go through so that the students know what we're talking about. And we have the key on that side, Cathy.
So that you can actually see exactly how many points that each one is worth. So we've got the evil mat right here, which is worth minus 40, and we've got the heart over here, which is worth plus 10. So that could be kind of useful.
And so it's the same idea where the students have to, we're going to show them what we want to see from them. So say we give them this route where they go directly up and then over to the end point, to the finish point. And we see that the course has taken us and intersected with the evil mat twice.
And so we've got this power graph over here, and up at the top the students are starting at 100%, right there. But as they intersect with the mat, unfortunately, they lose 25% of their power. So we've got a decrease in power. But they have to get past the mat, so they're going to, maybe you could show them, Ramona, where he comes out, where they come out again.
Okay, so this is where they intersected, and then they intersected again here.
So it's minus another 25. So we're already down to half power. This is terrible.
And then they pick up a life up here.
Oh, thank goodness we get to increase.
And then we get to our finish line. And then we have the students analyze the power graph to see if they made it to the finish line intact.
And so with this, what we're looking at is, what's it mean that just along here the line is decreasing, we're going down? What's it mean that all of a sudden we change direction? So you can tell that you're losing power, and then all of a sudden you start gaining.
And then we want to analyze that, saying, yes, we're losing power because we have a negative slope, and then we're gaining power with a positive slope.
The other thing we'd be looking at is, why is it that over here it's steeper, and over here it seems to be a little bit shallower? So looking at what that means qualitatively.
Okay, and so they get another worksheet where they will have equations that they're gonna graph out, and
once they've graphed that, that will take them through this map, and then we've got the power graph for them to fill in for themselves. And we were kind of mean on this one, weren't we, Ramona?
Mm.
We were really mean. You see, by the time the students actually follow all of these equations and get to the very end, they're kind of, well, how do we put it? Dead. They actually get down to negative 10% of their power. And so we're kind of hoping that our students will realize that they can't have negative 10% of their power. They had to stop before the finish line. And so the final question on this particular worksheet is there a route that you can use that won't kill you?
And then lastly, they have another worksheet where they get to choose waypoints and navigate their way through the obstacle course and trying to avoid the monsters. We're not necessarily trying to pick up more power, but you're trying to avoid the monsters so that you don't end up dead.
And at the same time, you want to get through the map in the fewest number of equations possible. So the first worksheet today, we would have graded with a, just for accuracy, did you actually know what you were doing? But for the second one, where it's got that creative component of how are you going to do this, we haven't told you what to do or where to go. So again, we're going to be looking at completeness. Did you actually answer all the questions? We're going to look at accuracy. Do your lines match your equations? And we're going to be looking at how creative or how clever were you about getting where you're supposed to be.
Yeah, again, we don't want to encourage the students to just have vertical and horizontal lines on these pathways.
So again, we'd have another closure discussion, how are NASA rovers like video games? And in this case, this is about power. So when you send out a rover, you need to make sure that it's got enough power to actually finish the entire mission that you've sent it on. Is it going to make it through all those different tasks that you set for it, or or is it going to run out of power before you get to the end? And if it's starting to run out of power, what are you going to turn off so that it can keep going and get as much done as possible? Some rovers are rechargeable. For instance, Spirit and Opportunity had solar panels on them. So again, you've got that power increase, just like we had the hearts to power up on our lives, but are you actually powering up as much as the energy that you're using, or do you need to stop for a little while and recharge sufficiently to keep on going? Or alternatively, are you using less power than you're taking in? Can we add a few more things to what you're supposed to be doing so NASA scientists actually analyze how that power is being used to get the optimum performance out of their rovers?
And so these are very important standards that we're teaching in first semester Algebra 1 classes, and they're going to be important standards that we're going to teach for the pre-algebra class. And like we had mentioned before, there are power standards for the California Standards tests and the California High School Exit Exam.
So we are definitely going to share these ideas with our pre-algebra team and our algebra team as soon as we get back to Bloomington High.
And since I'll be teaching Avid Juniors next year, or this current year, I'm going to use it as a review assignment with my juniors so that I can prepare them for the SATs and the ACTs. And as well, this is a really good lesson in teaching my students how to use collaboration, and so I could put them in pairs in their groups, and so that they can come up with the most efficient course through the map.
So what has this meant for us? We're definitely looking at how we can improve our lesson applications and how we can include more hands-on activities in our lessons from now going forward.
And what I really like about this lesson is that it is easily applicable into our classes, and hopefully we won't have too much resistance from other teachers.
The other nice thing about this is it could actually be taken by other teachers who aren't pre-algebra or algebra 1. We were thinking about it and we're going, you know what? We use linear equations all the time in Algebra 1, but what about quadratics in Algebra 2? What about parametric equations in pre-calculus or calculus? And so if you just substitute different kinds of equations into this, you could use it in any level of math class. Maybe you want to do it with the lower level students, then maybe you take out the part where you write the equations of the lines.
And focus on slope.
Or focus on just that parametric and reading the graphs. And so there's a lot of different ways that you could actually use this in other math classes rather than just the way that we have it set up. So when we get back to Bloomington High, we're planning on presenting a lot of what we've learned to the math department at Bloomington High, as well as we might have to report to the entire staff. But one of the groups that we're really focusing on is the pre-algebra team. I'm actually one of the co-leads for our pre-algebra team on campus, and I realized last night, it's actually interesting, all but one of our pre-algebra teachers are either here at KSC or attended another modeling workshop earlier this summer. And we're actually rewriting the pre-algebra curriculum this year, so it's going to be really, really influential to have had so much training in modeling and simulation, especially since modeling and simulation is going to be so important in the Common Core standards when they get implemented in 2014.
And I'm going to bring this to my Avid site team and implement it into our KC prep time, because a lot of what Avid does is prepare the 10th grade students for their KC exams. And it's just it could be a Friday activity where we work on team building, because it's a very good opportunity to work on collaboration for the students.
Sorry. Outside of our school site, we're actually looking at going to visit, say, some of our old teacher education programs. I've already been in contact with the university that ran my teacher education program. They're really excited. They can't believe that one of their interns had such a great opportunity. And so I've been invited to come back and talk to their math and science interns this fall.
And we're looking into getting into professional conferences. I'm getting in touch with the people who run the STEP conference. That's the Science and Technology Education Partnership. It's through UCR, University of California, Riverside, and we're waiting to hear from them. And we also had the opportunity to be interviewed by one of the local newspapers.
And oddly enough, the article is supposed to be printed either the day we get back or the very next morning, so it'll be interesting to go looking for a newspaper as soon as we get home. Let's see if it's in there. So thank you all. This has been an absolutely amazing experience. We feel very privileged to have worked here and to have worked with a mentor as wonderful as Rebecca, and to I've been shown around and supported by people like Les and Lena and Lisa. It's been a really wonderful experience, especially working with all of you, our colleagues.
Yes, thank you.